I think that in parallel with our study of proofs, it will be useful to start studying some of the elements of trigonometry as well, so we can kind of alternate back and forth and interleave problems between the two subjects. So let's talk a little bit about trigonometry. And the first thing I'd like to do is to dispel a common misconception. And this is even embedded in the name of the subject trigonometry, which shares the same word root as triangle. So one could reasonably be led to believe that trigonometry is at essence about triangles. But I think this is really a red herring, and I'd like to try to convince you of this, that really trigonometry is more about circles, and more specifically it's about kind of oscillatory or periodic phenomena. So let me try to explain what do I mean by that. So suppose we draw this unit circle, and by unit I mean we're going to assume that this guy has radius 1. So let me draw a radius going outwards and give this length r equals 1. So we could kind of construct a table here and ask the question, as you go a certain angle around the circle, what are the x and y coordinates of the point on the circle that you hit? So let me make that a little more precise. So angle, x, and y. So what do I mean by angle? So for instance, if I start from, here's the x-axis and here's the y-axis. If I start from the x-axis and make an angle of 90 degrees, so by that I mean I'm going to make this angle 90 degrees, that angle determines a point on the circle, right? That's the point up here at the top. And that angle of 90 degrees determines a point whose xy coordinates are 0, 1, since it's right at the top of the circle. So I'm going to start putting that in our table. Maybe I'll go to white. So I'll come back to 0 degrees in a moment, and then put 90 degrees here. So the angle of 90 degrees hits the point which has x coordinate 0 and y coordinate 1. And you can kind of imagine continuing this if we instead went all the way over to 180 degrees, then that's going to intersect the circle over here at this point, which has coordinates -1, 0. So in our table of values, if we ask at the angle 180 degrees, where does that intersect the circle? It's at x equals -1 and y equals 0. And we can start filling in some intermediate values as well. So my circle's getting a bit busy here, but we could ask about the angle 45 degrees. So 45 degrees, maybe I'll recycle this point I used for the radius, r equals 1. So what is the point on the circle which is intersected if this blue angle here, if the blue angle is 45 degrees? What are the x and y coordinates of this point here? Well, that requires us to remember something of our 45, 45, 90 triangles. So let me redraw that over here just to remind us. So this is the blue triangle where this is a right angle, and this is 45 degrees, and this is also 45 degrees. And this is where the connection with the triangle comes from, but it's really kind of an accident that the triangle happened. The triangle is really a red herring. It just came because you can drop a diagonal on the circle and create a right triangle. So what are the side lengths if this thing is 1? Well, remember for 45, 45, 90 triangles that the ratio of the sides are 1, 1, square root 2. So the hypotenuse is square root of 2 times the length of the legs. So here the hypotenuse is 1. So 1 needs to be square root of 2 times the length of one of the legs. So what length do I need so that when I multiply by square root of 2, I get 1? Well, the answer, of course, is 1 divided by square root of 2. So this length is 1 divided by square root of 2, and so is this one, right? Because now these are in the ratio 1, 1, square root of 2, since this is square root of 2 is large. So that means the x and y coordinates, since this leg on the bottom is the x coordinate, and this leg here, the vertical, is the y coordinate. These are both 1 divided by square root of 2, which of course you can also rewrite as square root of 2 over 2 if you prefer. But let me do that. And I think it's pretty clear the angle of 0, which is just this point here on the x-axis that intersects the circle there, that intersects at x equals 1, y equals 0. So you can imagine kind of defining a function in this way, because we remember that the general definition of a function is just a rule which sort of takes in an input and then determines a single output. We don't need to be able to write down all of the values explicitly, and indeed there will be infinitely many for different angles here, so we can't write them all down in a table. But you could imagine defining that function, which takes in any angle and then goes to the corresponding point on the circle determined by that angle, finds the x and y coordinates of that point, and then spits those out as two different functions. So the x-coordinate will be one function and the y-coordinate will be another. So we will give names to those functions that I've just described. The function which takes in an angle, goes to the point on the circle determined by that angle, and gives you the x-coordinate is going to be called cosine. And the function which does the same thing but returns the y-coordinate is going to be called sine. And if you forget which is which, you can remember that x comes before y alphabetically, and likewise c comes before s alphabetically, which is a helpful mnemonic, but hopefully it will be automatic eventually. The cosine is the x-coordinate and y is the sine coordinate. So to make that just a little more clear, in case this table of values thing was not entirely convincing, we go to this useful visualization over here on Wikipedia. So what's going on here? Well, let's start by looking at the circle down here. So this is the circle of radius 1, which I was drawing before. And we're doing that procedure I described where we go to some angle on the circle and find the x and y coordinates. And then we're going to plot those in two different graphs. So notice that this green point on the circle is getting traced up to this blue dot, which is giving us the x-coordinate, right? See, so for example, now it's x equals 0, now it's to x equals 1, back to x equals 0, x equals minus 1, and then we're plotting that on a graph here. So that's the x-coordinate, which is cosine. And we often use the angle theta, or really any Greek letter really is usually fair game for an angle. Theta is a Greek letter which corresponds to t. And in the same way, we're tracing the y-coordinate of that green dot over to this red point here, and plotting that as the angle changes. So this is giving us the y-coordinate on the circle as a function of angle, and we recall the y-coordinate is named sine. So this is again sine of theta, where theta represents the angle. So as we move forward with trigonometry, even though triangles do appear, I think it's much more fundamental and gives much more insight to keep firmly in mind the idea that all of this is coming from coordinates on the circle. So the fact that these graphs repeat, for instance, is simply the observation that as you go all the way around the circle, you come back to where you've started. So you would expect these coordinates to repeat. And that's really the key. Okay, so I'll end the first video on that note.